Happy Monday to everyone. Hope you all had a great Thanksgiving break. We are delighted to have all of you here. The session is with our customer Iridium. We have 3 distinguished members here with us on stage. We're going to talk about hybrid networks, the aerospace industry, the unique requirements thereof. But before we get started there, let's start with the intros. Mike, go for it.
I'm Mike Solomon. I'm a software and systems engineer at Iridium. My primary area of focus is constellation and ground networking and routing.
I'm John Stanfield. I'm a principal cloud architect at Iridium. I'm on the system architecture team, and we're responsible for the overall design of the constellation and all of the ground systems.
Yeah, and excuse me, I'm Marco Bavera. I'm the Associate Director of the Ground Network Infrastructure team, and my team mostly focus on the ground network and all the elements and connectivity between sites and within all the different sites.
Thanks, Marco. I am Srikanth Ramachandran. I am part of Fortinet's cloud consulting services. We are a global team with around 20 members, and we specialize in public cloud architectures, automation, and posture assessments. So they're the 3 big pillars that we operate in. And again, as I said, we are very happy to bring this session to you. Hopefully it'll be a good learning for all of you. This is how we used to look. So this is all an identity check for you. We are who we say we are. Vince unfortunately couldn't make it. His flight got delayed because of maintenance issues. So I'm going to play a double role here of Vince and Sri. So bear with me. So I just want to play this video for you.
Iridium is more than just a satellite company, making connections anywhere, to anything, or anyone. With an upgraded, state-of-the-art constellation, complemented by decades of experience, Iridium brings new energy and a forward-looking vision to the industry. There's no other network like it. Operating in low Earth orbit, Iridium is still the only commercial satellite system where calls and data are passed from satellite to satellite. The network provides low latency, weather-resilient services to the whole planet. Safety and reliability are in Iridium's DNA. Trusted by people and organizations in some of the world's most challenging environments, Iridium remains committed to helping make the world a safer place. And Iridium continues to innovate beyond satellite phones. The flexible Iridium Certus platform provides voice and data access at the fastest L-band speeds available. Iridium is also enabling the technology of the future, from real-time tracking to command and control for autonomous systems, and simplifying IoT application development beyond cellular networks. And all of this is made possible through Iridium's growing ecosystem of over 450 industry-leading companies around the world. As we look to the future, the possibilities are endless.
Hope you liked that video. Certainly when I saw it, it was quite an eye-opener for me. Iridium operates in areas of very remote locations. Could be the North Pole or could be in the middle of an ocean somewhere where the general satellite signals are not available. And so they operate and offer a critical service for their customer base. So let's hear a bit more about how that whole system comes together at a high level. And Mike, can you tell us a bit about how you make this happen for users?
Absolutely.
Oh, the next slide is. Yeah.
In fact, the video is a good introduction to a slice of the Iridium system that demonstrates the high performance and high availability that are inherent features of the Iridium network. In the video, we saw a couple of clips where user devices were being pummeled by rain and moisture in the atmosphere. We chose a specific spectrum in the available satellite to ground communication frequencies that is the most resilient to rain attenuation and moisture attenuation. So this story can be told from a particular subscriber device's end all the way into the constellation, and then how the data is grounded into the network. In fact, let's say you have an in-reach device and you're in a remote area and want to communicate an SOS message. And the scenario, as we saw in the video, is happening, and you have a rain event around you. Because of the L-band frequency, you're almost guaranteed that the message is going to get to the constellation, to the satellite that's directly overhead the subscriber device. Our resiliency, though, does not stop there, especially in relation to weather. It's extended to the opportunity to ground the data now through one of our teleports that are distributed around the world. In the constellation to teleport direction, we use K and Ka band frequency. That frequency is susceptible to rain fade. A lot of new systems are actually provisioning user devices to use the K and Ka band frequency. In our system, we built a capability to dynamically detect and route around a teleport that may be experiencing a similar set of weather event. And that ability basically increases the chance of that traffic to be delivered to one of the gateways significantly. And on the ground side, from the ground to the constellation side, similar story. Using off-the-shelf standard protocols, we also have mechanisms to route around failed teleports or rain-attenuated teleports that build in resiliency of end-to-end communication across the board. And it's really that set of requirements or that set of thinking that we apply when designing or architecting and designing and building the ground segments itself. And as part of our transition into the cloud, that's the availability model we're bringing to the cloud as well. Any component, whether it's the WAN link from the on-prem network to the cloud, and all of the components that comprise our presence in the cloud will be required to have that level of availability and have minimal downtime in case of disruption of the WAN link or the network element or the firewall, and even more significantly, the software applications that run the core network. So that's one slice through a pretty complex system that kind of sets the tone of high performance and high availability in our network.
Wow, phenomenal. I possibly heard you say the word reliable so many times, which kind of makes sense because this is a critical service, right? So let's just double click a bit more in terms of at a network level, which is the transport that makes all these systems come together. John, maybe you can share some insights in terms of what makes it unique? What is so unique about the systems that Iridium have to operate this kind of a service? Can you tell us a bit more about that?
Sure. Let's unpack that question a little bit. Let's think of a typical system, and then I'll compare Iridium's system to that. So let's use a cloud example. Let's say you have an application. Pick your favorite programming language, and you're running this on AWS, maybe in containers, maybe it's a Lambda function, maybe it's behind an application load balancer, connected to a transit gateway with a firewall behind it. All of the traditional, well-architected things that you find at Amazon Web Services. So at Iridium, we take all of that and we throw it out the window because a lot of it is incompatible with how we operate. We do really unique things. We use UDP, multicast. These are things that don't play nicely in the cloud. Not a lot of what we do is HTTP based, so application load balancers, those are gone. occasionally, network load balancers and things like that are available to us. But more often than not, we just have to get creative and figure out how to solve the problem. So that kind of tells you how Iridium compares to the typical system. But we can't sacrifice any reliability or anything. We need 100% availability of all of our services. For example, picture a person trapped at the bottom of a canyon, injured, and they have a Garmin device and they hit the SOS button. That signal has to reach the constellation, and it has to end up with emergency services. We're also running on the tsunami warning system in the Pacific Ocean. These are things that cannot fail. We need absolute reliability on all of them. So it's a little bit about what makes us different than what you might see in the wild.
Yeah, I mean, as I heard you talk, the UDP and multicast definitely throws a twist in the way we think. But having said that, all the well-architected principles still hold good, right? Performance, scaling, reliability, security, operational excellence. Of course, cost is always a factor that we need to build in our thoughts when we build this architecture in terms of choosing the right instances and whatnot. But as much as you are very unique in your requirements as you move to the cloud, the principles of architecting still remains the same, I would say.
That's where the creativity comes in.
Exactly.
You can't sacrifice any of those well-architected pillars.
Yep.
You just have to get creative in order to meet them.
Well said. So maybe Marco, you can expand a bit on the specifics of that technical requirement. How unique is your uniqueness in terms of maybe latency, maybe in terms of delays, packet losses, those kind of things, so that we can say how can we address this problem? How can we even approach this requirement from an AWS best practice architecture perspective?
Yeah, that's a very good question, and you probably have heard the word reliability 100 times, so you'll hear it 101 times from me now. When talking with network fellows and peers, and talk about network requirements, most of the time throughput is one of it's probably the first requirement that is discussed. Well, in our environment, reliability is the very first requirement. How do we obtain these high reliability? We obtain it by constant real-time monitoring of the status and the performance of our network. And we also need to make sure that whatever we add to the network, this hybrid network that has a space segment, a ground segment, a cloud segment, any element that is introduced, it has to be seamlessly integratable into the existing system. So yeah, we were saying reliability. Our goal is you can use the analogy of to describe our network, right? With the regular cellular, everyone here has a cell phone, right? And as we move, the user move, and the cell tower doesn't move, right?
Yep.
In our world, the user doesn't really move, relatively speaking. What moves is the tower, right? The satellite that moves. And we have to, so this to say what? That our network is a network that constantly changes, and we have to make sure that these changes do not introduce any packet loss, right? We strive to, our goal is any ground change, we want to converge within 1 second, right? Which is a very low timer, low value. We also want to make sure that those critical messages, whether you're hiking or you're in the middle of the ocean or you are at the North or the South Pole, you saw some of those clips on the video. That message is delivered reliably and as fast as possible, right? So we optimize paths. And And we do that by, as I was saying, by monitoring, not just constantly, but in real time, the status and the performance, right? We need to know if a link is available, but we also need to know if a link is performing at our standards. We measure anything that is above 0.05% of packet loss. We need to go find a better way to transfer that data. And the other aspect, as I was saying, is that the seamless integration. Iridium has been around for almost 30 years now. I started working on Iridium in 1996, so you do the math, and it was already going. The system has evolved, the system has changed, and that's what, in my case, made it a great job for me. It's always these adapting to new technologies, what's new out there. The cloud is a relatively new technology, right, so to speak. And we try always to bring in and optimize and improve and do things better. How can we improve our system? But again, throughout these years, we also have developed best practices. We have developed operational procedures and standards and way of we operating and managing and maintaining this network. And we want to make sure that all these best practices and all these lessons learned are transferred into all these new elements to the extent possible.
Right.
Because the case of the cloud, like I think John was saying, we have to adjust, and we had to. There were new lessons to be learned, right, on how we did that.
Okay, cool. This is now even more stringent than the voice over IP of 1% packet loss is acceptable, 150 milliseconds of one-way delay, 20 milliseconds of jitter. That kind of that was considered stringent. But again, if a few packets were to be dropped, you can ask the other person to repeat the conversation. But here we are talking about quite an extreme situation that they are in. So let me talk a bit about what's available in AWS as possible candidates for you to consider. And we'll go through one technology at a time, and feel free to ask me questions if you think that would be a fit. So the first option for you to consider when you migrate to the cloud is AWS Cloud WAN. This has been a service offered by AWS for about a couple of years now. And what it is it's a managed service built on top of transit gateways. So where if you have geographically spread presence, AWS behind the scenes takes care of all the routing and propagations like a fully meshed topology, because with transit gateways and peering, beyond a couple of regions, it gets pretty complex in terms of routing and all that. So AWS takes care of it all. And they recently introduced this concept called service insertion, because security is table stakes for everybody, right? It's never an afterthought. And so the ability to insert a third-party firewall like a FortiGate in the midst of these flows, be it east-west, north-south, south-north flows, that is something that was recently introduced. So having heard this, what thoughts come to your mind in terms of the reliability that you talked about, or operational excellence, visibility, that kind of stuff that you were talking about? What thoughts come to your mind in terms of whether this could even be a candidate?
Yeah, no, it sounds like a very interesting option to consider. The part that interested me or kind of caught my attention, couple of things. I'll talk about one of the two is the dynamic routing nature of it, right? One of the tools we rely on in order to reach the level
Yeah.
of reliability that we aim at, is using and leveraging dynamic routing protocols. BGP in and of itself is not probably the fastest converging routing protocol. But that being said, even we have been working with BGP. We use this overlay technology, and then we just basically, then you can run any routing protocol you really want, and even overcome some of the issues that are or limitations or issues inherent with the dynamic routing, that they leverage multicast protocols and that are not very cloud friendly and whatnot. So that definitely would represent a new step ahead, an improvement over some of what we encountered so far with deploying transit gateways. The other part that is interesting, and maybe I'll let Mike expand on that, is the geographical diversity, and providing this meshing of the network in different areas of the world. Because Iridium is global, right? We cover every single inch of the globe. So
so one of our tenants and envisioning a day where we can operate a hybrid network where we have significant assets in the on-prem and some assets in the cloud, is our ability to the extent possible, to seamlessly integrate, especially given the geographical distribution of our presence, whether it's teleports or gateways or concentration of users, that we would like to move some compute functionality closer to those users. That desired goal of having a seamless integration to the existing infrastructure, and not just in methodology and process, but it's also in know-how as well. So some skill sets may be very telco specific. The ability to kind of extend that into that on-prem and cloud from an operations perspective is a significantly important for sustainment. So.
I had a thought as well. You mentioned complexity of VPC peering and stuff like that. You can easily trip yourself up at scale implementing a solution like that. And I prefer transit gateways to alleviate some of that complexity. And I certainly don't want to see, I want to keep Iridium from falling into those pitfalls of complicated networking options. So if Cloud WAN is a solution that builds on top of transit gateway and alleviates some of that complexity without sacrificing any reliability, or maybe even adds to it, that definitely sounds like an option that we could consider.
If we think about what we need to think about, transit gateway peering is also manual. It's not automatic. So forget VPC peering. Transit gateway peering is also like statically routed and managed by CIDRs and whatnot. So Cloud WAN abstracts that, making it dynamic routing. But Marco, you were talking about, so it's one thing to have redundancy, but it's also equally important to reconverge in a quick enough time. And you were talking about BGP and the convergence aspect of it. That's something we need to think about. All that I'm saying is something we need to think about. And so that's one of the things that we do in cloud consulting is, first off, we are vendor agnostic. You might find it surprising that we say that, but we are allegiant to the solution. So in the system of systems concept that they're talking about, there's always third-party equipment involved. We need to make the solution work end to end. That's their business. That's our business too. And so when we walk through architectural options, be it Cloud WAN or other things that we're going to talk about, we also think about, hey, what do you get? What don't you get? Because it's an abstracted service in any cloud provider for that matter. There are knobs that you have control of. There are knobs that you don't have control of. BGP convergence. You would not be able to manipulate some of the fine knobs of BGP because that's being managed by the cloud provider, right? So whereas in an on-prem world, you would have been able to do it, the hello timers or whatever. Given that reliability is super critical for you, this is something to bear in mind that, hey, some knobs may be available, maybe not. Maybe not be available today, may come in the future. So all these things are part and parcel of our thinking in choosing the right architecture for Iridium, right?
Yeah. When you say, Sri, choosing the right architecture, we found one of the I don't want to call it an issue, but we found ourselves having to figure out a way to make it work with two different types of traffic, right? We do have a real-time traffic, which is very critical to us. And having to handle the failover and the convergence of real-time traffic. And then on the other hand, we have the management traffic. We need, again, it goes back to the two requirements I was mentioning at the beginning, right? The reliability and the fast convergence and the low latency of the user traffic, but then the monitoring. We need to be able to monitor the system so that we can automate and orchestrate the response to all the changes on the network, right? So what's your experience, or what have you seen out there in the industry? How do companies, not necessarily just Iridium, but how do they handle those or manage those two different types of traffic?
Yeah, this is a classic case of a divide and conquer. Not all elements of a system have the same kind of stringent requirements. Like the control plane and data plane that we typically talk about. Control plane is super critical, which has to get there, but not very traffic intensive. Data plane is bandwidth intensive, but it doesn't have to get there. Very similar kind of a thinking from what you're saying, and it provides us an opportunity to create something unique that one set of traffic will go through a flow that is low latency, recovers quickly and all that, and another set of flows can tolerate delays and can leverage some other aspects of it. It's not that one cannot leverage the other. One relies heavily on the reliability aspect of it. Another relies on the scaling aspect of it, right? So this is something that we can also think through, put it to test, and see how, at the end of the day, proof is in the pudding, that we need to test it out to see how it all works. So, for example, in the case of Fortinet, let us say we have Cloud WAN or even no Cloud WAN, we do service insertion with 40 gates. We will typically put a minimum of 2 40 gates across 2 availability zones for resiliency. And it can work in one of 2 forms, active standby or active-active. In an active standby, it's really like one logical box where they sync up the configuration. You can sync up session states as well. And then if there's a heartbeat going on back and forth between the two, and if one detects a failure of an AZ or a FortiGate, the other one takes over, right? And it also does things like updating the route table so that the new flows go through the new FortiGate rather than the old one. So we can, and because it's a FortiGate, we can reduce the timers of these to as low as 200 milliseconds for detection and recovery. Then after the detection occurs, then we need to initiate all these API calls for route table updates and whatever. Maybe we're talking a couple of seconds, but here you were talking about less than a second, right?
So, Sri, you're saying that there are differences, right, between these HA failover system in the cloud versus a similar HA failover system on-prem with the real hardware.
Yeah, exactly, because in the on-prem world, you use broadcast and multicast to be able to move across, which are not quite supported in the cloud world, to John's earlier point. So what Fortinet did was they created this protocol called Unicast FGCP. It's all an acronym world in the tech space, FortiGate Control Protocol. And so what it does is, because broadcasts are not allowed, it talks to the other FortiGate over Unicast, and that's how failures are detected and recovered and so on. But to your point on reliability of sub-second failover, this is really what makes this unique, that we need to make that happen. And so the traditional thinking of active passive and just downloading something from a GitHub repository, is unlikely to fulfill your requirement, which kind of leads me to this point of, given your unique requirement, what would be your approach in terms of engaging the right expertise to be able to, because you have a system of systems, you also have these unique requirements that's not typically addressed in stock standard solutions, which is fair because stock standard solutions available in GitHub or whatever caters to the mass, not quite to the uniqueness of this. So what would be your thinking in terms of how you would approach that to solve this problem? Everybody has finite time and deadlines. Nobody has infinite time or money. So how would you approach that from a solutioning perspective?
I can take a quick stab at it. I think the technology, so the cloud technology itself, as more and more telcos with these stringent performance and failover requirements begin hosting their systems there, some of the quote-unquote limitations that we talked about may be inherently addressed in the future. But for now, it's actually dual benefit for a system like Iridium that has, again, on the ground system, very much adaptive to commercial off-the-shelf and standard protocols, and on the constellation through creative but custom ways of matching, sometimes exceeding those performance requirements. Extending the ground infrastructure into the cloud, if there are ways to put an overlay network, for example, right? That overlay network on top of the cloud infrastructure that allows us not only to solve the availability question, but also the point I made earlier about extending our ability to transition into this cloud architecture by also retaining the skill sets and the know-how of and providing that seamless integration, which is, again, absolutely critical. So that is a step we could probably consider as part of the basic architecture. Again, looking at the rapid pace of technology development, I wouldn't be surprised if cloud architecture inherently supports or overcomes some of the, again, quote-unquote limitations just based on some of the requirements that we bring to the table.
Yeah, because there's one of technology and there's one of expertise to bring the technology together, right? So I was just thinking that the uniquenesses that you have presented is such that it is significantly unique. That's how I see it in my mind, that you brought up overlay technologies. We are talking about cloud WAN, active passive, active standby, maybe gateway load balancer comes into the picture. So putting all these together, takes expertise, even if technology is available, right? If only technology was that simple that you just plug it in, plug and play, then life would be easy. So maybe Marco, how would you approach from a project delivery perspective? What kind of resources and expertise would you be looking for to be able to pull this together, either from within your team or outside your team, that kind of stuff?
Yeah, it's one is leveraging the internal know-how and leveraging the experience that we have developed internally. But also the other aspect is asking experts out in the industry and for their opinion, for their knowledge. At the end of the day, we are exposed to some. It's hard to keep up with technology, right? Technology moves so fast, and so a company like Fortinet then has this larger view or use cases or business cases of ever run into these issues, right? Or going to conferences like AWS, talking to our AWS team and asking them, you are supporting similar customers. What did you see? What did you, without telling you how, because that's the secret sauce, right? At the end of the day. But there are definitely best practices and lessons learned that other people have, have been exposed to throughout their experience.
No, thanks, Marco. Definitely, I can vouch firsthand in terms of the engagements that we work in. So many times, in fact, just this morning I was responding to an email from a person who's having a tough time getting gateway load balancer to work, and I gave them some pointers. The reason I'm bringing this up is because technology, as easy it is to understand at a high level, when it comes to the nuts and bolts of getting this working, that takes a lot of expertise, that takes a lot of thinking and experience to be able to do this. So what we have to offer is reduce the business risk and also reduce the time to value. Of course, anybody can Google or use any of these Gen AI technologies to ask for recommendations, but at the end of the day, businesses have limited time, limited budget, and so they need to get that going. So that's our charter: make customers successful in their cloud journey, and the means to that end is be vendor agnostic and follow best practice principles, and that's how we've been living our life. Let's move to the next section of operational excellence. Observability, operational excellence. You talked about visibility, right? We cannot manage what we cannot measure. And I saw in the earlier video with this control center and so many panels in there. So what would be your requirement from an ongoing monitoring and management perspective? What would you like to see for your systems?
Yeah, the big screen is prime real estate in a control center, right? You cannot just throw any and every possible tool that you run in your control center up on the screen. I mean, you can, but you are going to make a lot of enemies if you do that. And it's not actually. I'm not suggesting or recommending it. So consolidating the monitoring tools, being able to monitor with the same tool assets that are on-prem as well as virtual assets, in the cloud, that's definitely a must. I mean, it has, like I was saying, we cannot just come up with put up a new tool to monitor the new, feature or the new device that we have.
Yeah, I mean, even if there is physical space to do it, imagine the ongoing operational cost of, monitoring it, managing it, and so on. It's yet another screen now, right? So what we have at Fortinet is, so I would split that visibility and management into two parts, one of visibility and one of management. So what we have to offer is our analytics engine, the FortiAnalyzer, and that could be on-prem or in the cloud. And it's the same one across all FortiGates, be it on-prem or in the cloud. And the special thing about it is, yes, it is a syslog collector, but it's not just a blind syslog collector that it just collects and stores the logs. Because the purpose of a syslog is to give some meaningful information and so that you're able to act on that. But because we have developed the syslog mnemonics and the messages, we are able to interpret those messages and then not only derive reports, but we have capabilities like the event triggers, wherein you can fire up an email notification if the CPU goes beyond 50%. We need those proactive alerting so that we can take some action ahead rather than not knowing about it and it hits 80-90%, right? So that's one part of the analytics and logging, which is essential for your observability. And the ongoing management of it as well is our manager, the manager of FortiGate platforms, which is, again, be it on-prem or cloud. The manager can be on-prem or cloud. It not only does policy management, it does all the configuration CMDB capabilities, like keeping configuration backup so that you can revert back to an older configuration. You can do operating system upgrades and so on. And you can even take a look at some of the latest announcements, product announcements, and so on, upgrades, what is ready for an upgrade, and so on. So this kind of a centralized logging and management is something that Iridium will find very helpful so that you're always keeping a tab. And some of the reports, the pre-canned reports that come with the FortiAnalyzer gives you some great insights, top users, top traffic, those kind of things. And it also gives you a graphical report of FortiGate performance. It's a pre-canned report. You can see average CPU, max CPU, average memory, max memory, network throughput by device. And you can group all of them as one cluster and then see the reports. And you can automatically generate so many. I can go on and on about this, and it'll bore the hell out of people. But but that's important. Unfortunately, I think this operational excellence is kind of sometimes an afterthought for people. And when we do our engagement, we even test high availability. We want to see that failover. How does it work? Do sessions survive? Don't sessions survive? That's the opportunity to do that high availability testing, rather than say, hey, I've got the configuration, it should work. No, it can't be this, it should work. It should be it does work. And we document the test plan, the results, and go back and see what we missed. And so these are some of the, and we also guide customers on operational best practices, enabling termination protection perhaps, right? So for critical devices and services, that's very important. What if somebody accidentally terminates a device and the device is blown off? So these are things that we give guidance. So we just not focus on the architecture part of it to make things for the requirement. We also think about it from a life cycle perspective of operational excellence in terms of how the whole thing comes together as one big solution. We want to get it to stand the test of time, whatever the test of time is. In the technology world, things are always evolving. And as a technology company, we try and keep up with those trends as well. Any other questions that you may have about any of those pillars, performance, reliability?
I wanted to ask John if
Sure.
What kind of if he ran into any specific issue or had to, but any specific challenge or any challenge that we ran into while migrating some of these workloads to the cloud, especially as it refers to, as we were saying earlier, the differences between the real-time traffic versus the management traffic,
Right.
or
just being able to access the resources.
One of the pillars that we haven't discussed too much today is cost management.
Yeah.
We've talked about a lot of complexity, different traffic paths, different types of traffic. In my head, that leads me towards, multiple devices, a large cloud deployment, lots of CPU and whatnot deployed out there, and a high cost.
Yep.
So one of the things that we tackle, we try to do it up front. That's usually the best way to do it, but sometimes it comes later in the game. It's like, wait, this is great. We didn't sacrifice any reliability, any security, but gosh, it's expensive.
Yeah.
So I think Marco's question was, what's one of the challenges? That was one of them. How can we do this in a way that it's actually economically feasible and low cost without sacrificing any security?
Absolutely. So AWS, I'm talking about native tools in AWS that's available. So what you do is you create, you need the underlying data of CloudTrail logs and EC2 instances and all that. So once you have that underlying data, and there's a process to go through for that. So what you can create is dashboards in QuickSight, AWS QuickSight, and those dashboards there are three big dashboards: the Kudos dashboard, the CID, and the KPI dashboard. And you can drill down into the details specific enough to say that, hey, which API calls through my CloudTrail is causing the greatest expense month over month. And you can go back to the application developers. CFOs can say, I want to track against these metrics and see how I'm tracking against these metrics in terms of leveraging ARM instances or Intel-based processors. You can do all of that stuff through dashboards, very graphically made for this kind of easy visualization and a drill down. So that is something that we also have to offer, because as John, you mentioned, cost again, as much as it should be everybody's responsibilities, even as easy as setting up budget alerts, it unfortunately is not. That's what we see in the industry. So these kind of setting up these dashboards and making it part of the ecosystem and the culture in a company, we see it as very important. So one of the things that I also want to add on is the Fortinet, you would have heard the security fabric. And this is for all the architects here, this is something that you will really like. Because a product does its stuff, agreed. But it's also responsible in a way to share its threat intelligence and telemetry with other products for what it cares about. Almost like teamwork. Imagine having 10 people in a team and nobody talking to each other, right? So how effective could that team be? So one of the things that we do at Fortinet is focus on the security fabric. And that is about intercommunicating products for what that product has to offer. Could be an endpoint product, could be a network product, perimeter firewall, you name it. Whatever that is, it doesn't matter. If an attack vector comes in on one, it shares that with others so that they can put in the due protections through automation. We're also big on automations. We offer APIs and connectors to talk to others, API to talk to us. So we make it an open system because we believe in distributed defense, not in a centralized defense. So everybody has to do their part, and if you all do it together, because attacks are very sophisticated. They only have to get lucky once. We have to get it right all the time.
Yeah.
So,
in a sense, I see an analogy there.
Yeah.
We both operate in a complex industry
Yeah.
or environment, right? And
Yeah.
all has to integrate seamlessly, and everything has to work seamlessly. You have the fabric, and we may have to come up with the fabric, I guess.
right.
But definitely security is also. I mean, earlier I was kind of listing some of the requirements that are key or, I don't know, specific, not unique, but specific to Iridium. But one of the pillars is security, right? It all starts and it ends with security. We have to maintain security. We are compliant. We need to make sure that all this data is not just like moved across reliably, but it has to be safely and in a secure manner.
Yeah, pretty much every packet, every flow has to be inspected by the firewall. The right policies have to be put in place. If you need to do man-in-the-middle inspection, that kind of stuff, you need to do that too for encrypted traffic. So the deeper you go, the more sophisticated. And FortiGate has always been a pioneer in high-performing equipment. We pride in our engineering excellence to be able to make the most out of the underlying resources in the cloud. And so these are the capabilities that enable this kind of advanced security inspection to be operational at scale. So one of the other things that I also wanted to share was maybe a couple of years ago we introduced this concept called flex licensing. And so prior to that it was either bring your own license where you buy the license out permanently or pay as you go. So FortiFlex licensing, from a capability perspective, it is like BYOL, but it is not tied to a particular FortiGate. So it's like managed centrally, and you define the configuration, and you dynamically download that token from the cloud and instantiate the FortiGate. As long as it's running, it will consume the points, so you can buy 100,000 points, and all devices, even on-prem devices, can leverage that and use that. So
it's another way to manage costs.
Manage costs,
exactly.
exactly.
John was
Exactly.
talking about
Right.
earlier. Yeah.
Because today you may say that I need a PMO8, and then operationally you manage monitor and you say, hey, this thing is not even doing 20% CPU, because this whole scaling is not exact science. Yes, we think we'll get to hit so much traffic. We think it's going to hit this kind of CPU based on our tests, but it's never exact science. So the reality is the exact science. And when you see that, you say, I'm spending too much money on a VMO8, I want to do a VMO4. So in a perpetual license, you bought it. So it's yours to keep. And you can scale down the number of CPUs on the underlying instance. But now with FortiFlex, you can just change the configuration from VMO8 to VMO4, and now you're just paying for VMO4. And that remaining capacity can be used elsewhere. So
that sounds pretty cool. It's kind of like how, let's say you have an application running on a T3 X large, and you find out it's using too much. You cut it down to a T3 medium.
Yep.
That's how you do it at the hardware level. You're saying you can do that at like the licensing level?
Absolutely. So if the underlying, you never want to over provision or under provision the number of CPUs that you have on the underlying instance. So if the underlying instance was an 8-core CPU and you had a VM08 and that was over-spec'd, you bring that down to a 4-core CPU, whatever instance that is, and put a VM04 on it. That way you save on cost to the provider, cost to Fortinet, which you can redeploy as be it on-prem or in the cloud.
Yeah. Through this whole discussion, I'm just thinking, kind of going back in time a little bit, and just made me think of all the trades that we had to go through, right? And all the pros and the cons of, again, putting together a complex system and network and the different technologies and the different layers of expertise that are required, right? To different bunch of brains to get together and just like murder board it, or however they say it, right? Whiteboard everything, all these sessions, and going back and forth and trading pros and cons. So it's pretty remarkable. It's complex. It's a long process, and
it's very collaborative. The approach has to be collaborative, and you go through iteratively. Start small, test, grow. That's the only way to do it, because yes, all the theoretical architectural thinking is extremely important, but it's not sufficient. It's like the math thing, right? Necessary, but not sufficient. So that kind of a story comes into play. Using these 40 flex points, you can draw down on your EDP quotas as well. A lot of customers have EDP quota committed spend to AWS. You can draw down on those quotas as well because Fortinet is in the marketplace, be it for next-gen firewalls, web application firewalls, you name it. It's all in the marketplace, and when you run it on AWS, it all counts towards the EDP spend.
Okay.
Cool. So I think we are nearing the end of the session. 8 more minutes to go. Unfortunately, we can't take questions here in this silent audience. We strongly encourage you to visit us at the booth or outside after the session is over. I really thank all of you for being here, spending the Monday afternoon with us. Wish you all a great rest of the AWS sessions, but please do stop by at the booth, and we'd be happy to take your questions in detail. Thank you so much.
Thank you.
Thank you.